This is Ham College, Episode 6 for June 30th, 2015. This episode of Ham College is brought to you by ICOM. Get out and get mobile with ICOM. Good evening and welcome to another exciting episode of Ham College. This is number 6, Tommy.
All right.
So we've got some special stuff lined up tonight. We've got some, well, gratuitous oscilloscope action.
Man, we've made it through half a year now.
We have. Actually a little more than that, because if you count the pilot episode, and we always do.
Yeah, well, we count everything we can count.
Yeah. Let's talk about a couple of things we want to mention before we get too far along here. The first one is, whenever we're doing the Ham College shows here, we've got a chat room. You can join us at AmateurLogic.TV/chat, and that's the official chat room. We got a few guys just popping in there right now, and we could actually have some ladies in there before the evening's over.
It's happened before.
It has happened before. But you know, we'd like you to join us there. If you're watching live on YouTube, well, there's a chat room there, but we're not in that one.
Yeah, we don't have any way to monitor that one. So leave that one and come on over to the one that's on the bottom of your screen right now and join the rest of the party.
Yep. And what a party it's going to be. We're going to pull out the diodes after a while. You know it's going to be dangerous.
We got some diodes, we got a transformer and electricity and an oscilloscope. So you know that's going to be making this some big fun right there.
Oh boy.
It might be like 4th of July.
Could even be some sparks in there. Well, last month, what did we talk about, Tommy? I know one of the favorite subjects that you had last month was this guy right here. Who is this?
Ampere.
You don't.
I forgot. We've done some. Okay, we had to back up a little bit, but we've done so many of them, I can't hardly keep them straight, man.
Yeah, this was the guy with the lady's name. It was Andre Marie.
And he's got the hairdo to go with it.
We measured some current. We pulled out an ammeter there. I meant to show this last month, Tommy, and somehow we missed it. I wanted to talk a little bit about series and parallel for those who really don't understand what's what. You can see on the top there's 2 resistors there. Those are connected in series. In other words, the current will enter, say, on the left-hand side there and exit on the right-hand side. On the bottom there, we had some parallel ones, and you can see those 2 are connected side by side there. So the current enters both of them at the same time there and exits at the same time. On the top up there in the series circuit, you see we've got 2 100 ohm resistors. We can just add those 2 together and we've got 200 ohms there. What about the bottom, Tommy?
Yeah, if you hook them up in parallel, it's going to actually divide it, and you'll get half of the value of the resistor.
Yeah, if they're both the same value.
Otherwise, you can add them together, I think, and then divide it by 2 or however many.
Yeah, there's a formula you can do that when you've got 2 resistors and they're the same value. I just use one with reciprocal there that works with anything. It's 1 over whatever the resistance is plus 1 over the other resistance, and then 1 over all of that. If I don't have a calculator handy, Tommy, but 50 ohms sounds right to me.
Yep, 50 ohms. I'll buy that.
Here is how you would hook up your voltmeter in a circuit to measure voltage. You can see we've got it in parallel across that LED there. Essentially, we're using 2.5 volts there. The LED resistance, roughly 300 ohms. We can see the voltmeter down there is measuring 2.5 volts. If we wanted to measure the current, we'll just add a meter in there in series. You can see in one leg of the circuit there, we've got 2.8847 milliamps.
Mm-hmm.
So that's how you would hook an ammeter.
Right, and your meter would actually become part of the circuit in this situation.
Yeah.
That's
So
when you got to watch the rating.
So ammeter there in series, as you can see, and down below you can see the voltmeter connects in parallel. So that's something we really should have talked about last month, but somehow it just kind of got left out.
Right, yeah, it's a good point. I'm glad you brought that back up.
So that's pretty much last month's show, or the things that we talked about in it, plus all the questions and answers from the amateur technician exam. We've got a little more old stuff to talk about, and this is your part of the show, Tommy. It's what we call ham radio history.
All right.
What are we going to be talking about tonight?
Well, today we're going to talk about diodes and rectifiers.
Both.
Yep. There's
They're the same thing.
right.
Yeah. Speaking of diodes, here's one now.
Yeah, there's one. It looks a lot like that. In electronics, a diode is a component that restricts the direction of movement of charge carriers. It allows an electric current to flow in one direction, but essentially blocks it in the opposite direction. Thus, the diode can be thought of as an electronic version of a check valve, or like a backflow preventer type thing.
Backflow preventer.
Yeah.
Okay.
You heard of that?
I've heard of that, yeah. I've never experienced it myself. Yeah.
You probably don't want to.
But that's one of the arrows in the diode symbol there, is just kind of symbolize that the current's going in one direction.
Mm-hmm. The first diodes were vacuum tube devices. They're called valves in the UK and down under where our friend Peter lives.
Yeah.
Today, most common diodes are made from ultra-pure semiconductor materials such as silicon or germanium. The word diode was created by William Henry Eccles in 1919. The word diode came from the Greek word di, meaning to, and ode, meaning path. As far as history of diode goes, there are several types of diodes, thus several people are credited with discovering the different types. In 1873, Frederick Guthrie discovered the basic principles of operation of thermionic diodes. And I probably butchered that up, but I'm going to stick with that.
That sounded close to me.
And in 1874, a German scientist, Carl Ferdinand Braun, discovered the unilateral conduction of crystals. There are others as well. And then that is an amazing mustache, I have to say.
Yeah, I would say it took a lot of wax to pull that off.
No kidding. The most common function of a diode is to allow electric current to pass in one direction. This is called the diode's forward direction, while blocking current in the opposite direction. This allows the diode to be used as sort of an electric version of the check valve we mentioned earlier. This single direction behavior is called rectification. Rectification is used to convert alternating current to direct current, including the extraction of modulation from radio signals in radio receivers. These diodes are forms of rectifiers.
You know, they had rectification in the school I went to, but well, it was kind of electric, yeah, a little bit.
Yeah. And so many inappropriate jokes could be made out of that, I guess.
Yeah.
But there's a lot of uses for them. I have a list of them here for radio demodulation, power conversion, over voltage protection, logic gates, radiation detectors, temperature measurements, waveform clipping, all kind of things.
Current steering. Yeah, there's a lot you can do with diodes, and that's why I always keep one handy right here on the set.
And you keep it in your wallet?
Yeah, I keep it in my wallet. We'll be pulling. Boy, you can't even see that, can you? There it is.
It's pretty small.
It's pretty small.
You could show the picture.
I could show the picture. As a matter of fact, I think I did show the picture. There you go. That is a small signal diode there.
Yeah. But they're pretty neat devices.
They are pretty neat devices. As a matter of fact, I also have a bridge rectifier here. This is like 4 diodes in one. Well, you can't really see that either. There you go.
I got a question for you about a diode, a Zener diode.
Zener. Yeah.
Zener? Okay, that's one that will prevent the backflow of voltage up to a certain amount of voltage, I believe, and then it will allow it.
A Zener diode will start conducting at a certain voltage.
Right.
So In other words, say if I had a 9-volt Zener diode and I put it across a circuit there, as long as I was applying less than 9 volts to that circuit, that diode's not
Oh, it's not going to pass
active.
through at all.
It's not going to pass
Oh, okay.
through.
So if you had a voltage sensitive piece of equipment, you could put one of those
Yeah.
in the forward end
But
of it.
what would happen is you would wire it in the circuit such that essentially it would short the voltage out. So as you increase and you got over 9 volts, that diode's just going to kind of like clamp down there and just hold it at 9 volts.
Okay.
Now you'd have to have some other components in there because you just can't go willy-nilly sticking diodes across circuits. That's not a good idea.
Yeah.
But yeah, that's kind of how it works.
It's not a good idea. I'll
Not
be
a
right
good
back.
idea.
I need to run home. Project I was working on.
Let me put these out of your reach. Well,
Okay.
we're going to do a little project here to play with those diodes a little bit, and as promised, the gratuitous oscilloscope scenes. That's all coming up, but first we need to get a message from ICOM here while we set up. We'll be right back with you. Get out and get mobile. Whether you're looking for a handheld, mobile, or HF rig, ICOM has a radio to get you operating on your next adventure. Take ICOM's IC7100 D-Star radio with you this season. An angled control head and touchscreen provide user-friendly operation. A large internal speaker delivers clear digital audio, and it's perfect for multiband and all-mode communications. Interested in easy hands-free operation when you hit the road? ICOM's analog IC2730A mobile and the D-Star ID5100A both feature optional Bluetooth capability, a large backlit screen for high contrast viewing, and 50 watts output power on both VHF and UHF. Go far with ICOM's D-Star dual bander, the ID51A Plus. Check out the Near Me repeater function for D-Star as well as analog repeaters, free downloadable RS-MS1A Android app, plus integrated GPS. Hit the trail with ICOM's IC7410. This HF rig is solid in performance and construction. High-grade DSP, all-mode operation, easy menu and ergonomic dials, and large heatsink for a heavy duty cycle operation. Make sure you visit icomamerica.com/amateur for more information on ICOM's complete line of amateur radio products. Stick your tongue to this and tell me if it's active.
Well,
This is from a 9-volt wall wart.
don't be poking that over here.
We can actually check that out real quick. Let's just look at our scope here. So there we're looking at the 60 cycle AC wave there in yellow, 11.9 volts RMS. So that's AC voltage. Where the blue line here in the middle is would be 0 volts. Everything above that line is where the waveform is swinging positive. Everything below it is where it swings negative. So it's constantly sitting there swinging from negative to positive since it's an AC signal. Now we can take a diode and put in series there and change things up a little bit. So what I'll do is disconnect one leg of that AC voltage there, and we'll put a diode in series with it. And we'll hook the other end of the diode back to our scope. Now what you can see here is that we're only getting the positive halves of the waveform there. It's being chopped off right there around 0 volts. So we're only getting half of the voltage there, roughly. Well, I say half, that's not exactly right. It says 8.74 volts here. But what we've got is pulsating DC. That's because it's DC impulses. You know, there's nothing below 0 volts there. It's all in one direction. Now, this is its 60 cycle rate. So essentially, we're only being able to use about half that voltage there, or only use it half of the time. Because only when it's swinging positive here do we have any voltage. All this time that it's flat line down here across the bottom, and there's a little tilt to it, but all this time the voltage is essentially cut off from our circuit. We're not getting any benefit from it. So you can see here the anode and the cathode of the diode. you know, when this symbol was originally made, we kind of thought that the positive part of a charge is what flowed. So that's the reason the arrow's going in that direction. So we can just think of the positives are coming through that diode. It's only going in one direction toward the cathode there. That's basically what's happening. The diode is, like you said, a check valve, only lets the current flow in one direction. All right, there's a diode circuit that we can build that uses 4 diodes. Here's a bridge rectifier. It's 4 diodes in a package there. There's 4 leads on them, and they're wired like this right here. As you can see in the diagram there, we've got essentially 2 pair of diodes there. The ones that are blue on the left-hand side there, you can see their cathodes are connected to either side of that AC transformer secondary there. The 2 red diodes, their anodes are connected to the 2 secondary leads of the transformer. And you can see the 2 red diodes, the cathodes are connected to positive. The 2 blue ones, the anodes are connected to negative. Essentially what that does is when that signal swings back and forth from positive to negative, we're always getting that voltage.
Oh, okay.
In other words, you know, when we were looking at just the regular diode here, you know, we only saw current flowing when it went positive. So the negative half of the voltage we were essentially wasting.
So it's basically going to inverse that bottom half.
We get to use
twice the peaks.
We get to use both halves of the cycle.
Oh, that's cool.
Of an
that's
AC signal there. So let's hook it up. This one actually has it drawn on there. There's a picture of a waveform on 2 corners there, and then a negative and a positive for the other 2 corners. So we're going to put the AC on the ones with the waveform there. And now we're going to, the one marked negative, I'm going to put the negative oscilloscope terminal 2, and the probe will hook to the one that says positive. And we're going to take our other probe and we'll just hook it across, across one of the diodes there. So essentially what we're seeing, if we look here, let me turn off. Okay, now we're only looking at across one diode here. We can see we've only got voltage when it swings positive. It's chopping off right there at 0 volts. So half the time we're wasting voltage, or we're not conducting. We're not using that voltage. All right, so if we turn back on channel 1 where we can see it at the same time, look at here. What we're seeing now is that there is a positive spike there twice as often as there was when we were looking with a single diode. So we're taking advantage of both halves of that waveform. So in the blue here, essentially what we've got is a 60 cycle, or half of a 60 cycle waveform. The yellow here, we're getting both halves. It would be 120 hertz here if we measure that with a frequency counter. So we've got pulsating DC still, but the pulses are twice as often. So we've increased the duty cycle to twice as much. When you're building power supply circuits, you'll find that doing it like this, you're going to get more voltage in your supply, more efficiency. It's also, there's another thing that it's going to do. You know, if you look there, this is pulsating DC. There's going to be a ripple there. If we're just looking at say this right here, there's going to be a 60 cycle hum roughly that we're going to be hearing. That's across a single diode. If we put it across a bridge rectifier though, we've increased that frequency to 120 hertz. That means the value of a filter capacitor that we use will change too, because we've changed the frequency.
Right.
We don't have any filter capacitors handy here today, so we're not going to look at what that does.
Yeah, we haven't talked about the guy that invented those yet.
No.
It's probably coming up pretty soon though.
Yeah. Andre Marie capacitance.
One day we're going to have to take all these parts that we've been talking about and put it all together.
Yeah. So that's basically diodes there. There's a lot more to it. As Tommy mentioned earlier, there's Zener diodes, there's detector diodes. What we're showing you here is just the very basics of a diode. You know, what a half-wave rectifier would look like would be this. We're only getting half of the waveform. A full-wave rectifier would look like this. We're getting both halves of the waveform, or we're actually using both halves of it. When it swings from negative to positive, you know, there's a little dropout in there, but when you hook a capacitor across that circuit, it's going to smooth it out to where you've got pretty much just a solid line of DC across the top here.
Cool.
I should have pulled a capacitor out so that we could look at that. That would have been
that would have
fun.
been interesting.
Yeah. Could have made a little smoke too, you know, some nice popping
well, we
sounds.
still got naked wires here.
We do still have
And
naked
the night's
wires
early.
there. Well, yeah.
I mean, these could touch before it's over with. You just
Well,
don't
it
know.
could. It could.
I need to go get my welding goggles out.
Yeah. Well, I tell you what, let's take a moment here to pay tribute to our parent show, Amateur Logic, and get this stuff out of the way and get on into the question. On the 15th of each month, ICOM is proud to sponsor AmateurLogic.TV with hosts George Thomas, Tommy Martin, and Peter Barrett. This looks a little crude, but roughly here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
Actually turn that into a scanner capable of tuning across a wide range of frequencies.
Whoa, okay.
What is this called?
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas via the switching matrix.
Down in Melbourne, apparently they tune up their radios different than we do, Tommy.
Oh, yeah?
Now, the FM 900 is tough. Seriously tough.
We finally arrived.
Man, we were in Ham Nirvana.
Again. Boy, what a great time. And as happened last year, we still haven't got all the way through the flea market yet.
No, we've hit about a fourth of it, but we're going to have to strike a trot.
Well, the moment of truth has arrived. I've attached a B&C connector to the antenna terminals here. I've got plus 12 volt in ground power coming in here. It's going to my power supply. That I'm supplying it with 13.8 volts.
And I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack, and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
Wow, that explains a lot.
All right, Tommy, sing the theme song here. Some questions from the technician exams. You know, that's probably one of the big things that we do here, is to try to prepare you to take your amateur radio exams. We're starting with the technician exam, of course. You're going to want to do more studying than you can get from us, because with the show only once a month, it'll take you a long time to go through all of them.
The question pool will probably be expired.
Yep. So we're just trying to kind of get your mouth watering about taking the exam and kind of get you primed to go do some other study. But, you know, we're going to try to cover them in enough depth here that you understand.
Yeah, and
you know,
kind of go through the process of reasoning out the answers.
Yeah.
And
All right.
get
So
a good refresher ourselves. I do want to say, I think we failed last time to mention it, but when we were in Dayton, we actually met I think he was the first Ham College graduate. You remember him coming by right before we did this live show?
Yep.
And I wish I had his call sign with me. I think I've got it at home. But anyway, congratulations, whoever you are.
Congratulations. Hopefully there will be some more coming in the class.
Yeah. Oh, yeah.
Well,
we'll have to have a ceremony.
Well, let's get on in with our first question here. I'll read it and you can answer it. What is the only time an amateur station is authorized to transmit music? A, when it's incidental to an authorized retransmission of manned spacecraft communications.
B, when the music produces no spurious emissions.
C, when the purpose is to interfere with an illegal transmission.
Or D, when the music is transmitted above 1,280 megahertz.
Okay, Tommy, why don't you reason this one out for us?
Yeah. Well, I think you're really not supposed to transmit music anyway, not
Yeah.
intentionally. And actually, I know you're not, because that's considered broadcasting.
Yep.
So, A, when incidental to authorized retransmission. Incidental was what gets my attention there, so I'm thinking it's probably A. So, but let's go through the rest of them. When music produces no spurious emissions, no. When the purpose is to interfere, no, that's illegal on its own to interfere. Even interfering with illegal transmissions, that makes you just as bad.
Yep.
So, or when music is transmitted. So, transmitting music is illegal from the start. I do remember that.
Yep.
And so it's got to be A, when incidental to an authorized retransmission of manned spacecraft communications.
Well, I think you may be right there, Tommy. Most of the guesses there in the chat room are A. There's one he changed his mind. Mike said D, but then he said A. Yeah, it's going to be A. I think you're right. Let's find out. And you're correct.
Ding, ding, ding. Oh, fist bump. There we go.
When it's incidental to an authorized retransmission of manned spacecraft communications. So what actually does that mean?
Well, that actually means Mike put a comment on the chat room that says that he forgot that the International Space Station sometimes has music in the background, and that's true.
Ah, okay.
So that's not illegal for them to do that. It just happens to, if the mic picks it up, then it's okay.
And I guess the reason they said a manned spacecraft is because otherwise you could just find some music on a satellite and broadcast it, and that wouldn't be kosher. No.
So that's it. That was interesting.
That was interesting. Well, let's move on to the next one here. Why don't you read this one?
All right. When must the station licensee make the station and its records available for FCC inspection? A, at any time 10 days after notification by the FCC of such an inspection.
B, at any time upon request by an FCC representative.
C, after failing to comply with an FCC notice of violation.
Or D, only when presented with a valid warrant by an FCC official or government agent.
Yeah.
Well, it's my turn, so I think it's obvious that it's going to be B.
Yeah.
And that's what they're saying over in the chat room there. Well, let's see. A, at any time 10 days after notification by the FCC. No, you don't get 10 days to hide your illegal gear.
Yeah, that's too late.
C, only after failing to comply with an FCC notice of violation. No. D, only when presented with a valid warrant. No. It's at any time. If the FCC knocks on your door, you're going to have to answer.
Yeah.
And there's people who haven't, and we read about them in the papers.
Yeah, every now and then.
Yeah, every now and then. So, no, if the FCC comes and they want in, you got to show them your station. I mean, that's just one of the things you got to comply with, for the privilege
of having your license.
Mm-hmm. So let's see if we're right, and we are.
You go, man.
Which of the following services are protected from interference by an amateur signal under all circumstances? A, citizens radio service.
B, broadcast service.
C, land mobile radio service.
D, radio navigation service.
All right, which do you think, Tommy?
Citizens radio service. Interference. That's citizen CB, right?
That's CB, yeah.
Broadcast service. You know what? You would almost think any of them, but I think it's got to be one.
Well,
There's
yeah,
not
there
an
can
all
only
the
be
above.
one. Yeah, I think you're on something.
There's no all, there's no all of the above there. So
Yeah.
radio navigation service, land mobile. I'm going to go with D, radio navigation service.
Well, that's what they're saying in the chat room over there. Da 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 da.
Yeah, so that's like GPS, things like that, which could cause pretty bad problems. If
Well, or that's like aircraft navigation systems.
yeah, oh yeah.
You know,
Telemetry.
you're talking about potential loss of life.
Yeah, so that's
So
I'm going with that one.
there you go.
Oh, I got
You
kind of
got
lucky
it.
on that one.
All right. Well, next one.
What may result when correspondence from the FCC is returned as undeliverable because the grantee failed to provide the correct mailing address? A, fine or imprisonment.
B, revocation of the station license or suspension of the operator license.
C, require the licensee to be re-examined.
Or D, a reduction of one rank in operator class. And let's see, it's my turn. So
Yeah, I think that was pretty obvious.
I think it's pretty obvious. If the FCC sends you a letter and it's returned as undeliverable, I don't think you're going to be fined or sent to prison.
No.
So we're going to throw out A there. B, revocation of the station license or suspension of the operator's license. I think that's the most likely thing that's going to happen there. C, require the licensee to be re-examined. Well, that's not the right answer.
That
but
might be the result.
That might be the result, yeah. You may have to get relicensed because you're going to lose your license. Or D, a reduction of one rank in operator's class. That's kind of a crazy
Like the
answer.
military, have one stripe ripped off.
So it's going to be B, no
Yeah,
doubt about
I
it.
would have to concur.
And that's what all of them in the chat room are saying as well. Revocation of the station license or suspension of the operator license.
Mike said you're demoted and shall wear ribbons of shame.
I think that's in Canada. I'm not sure that it's that way here. But this is why you are required to keep your address updated with the FCC.
Right.
And I know there's some people out there who don't do that. You can look them up and see that obviously the address is old that's on there. You got to keep that updated or you could lose your license.
Yeah, and it's so easy to change it. You can do it online.
Mm-hmm.
It takes like 3 minutes to do it. It's
Yep.
really easy.
When may amateur radio operators use their station to notify other amateurs of availability of equipment for sale or trade? It's A, when the equipment is normally used in an amateur station and such activity is not conducted on a regular basis.
B, when the asking price is $100 or less.
C, when the asking price is less than its appraised value.
Or D, when the equipment is not the personal property of either the station licensee or the control operator or their close relatives. That's a lot of conditions right there, so I'm kind of ruling that one out already.
Okay.
I just don't. I'm going to work my way backwards here. C, when the asking price is less than price, I wouldn't think price would have anything to do with it.
Yeah, I would.
B, when the asking price, there's another price. A, when the equipment is normally used in an amateur station as such availability is
Activity.
not activity. Yeah, sorry, that's kind of small. I'm going with A.
You're going with A.
Final answer.
That's what everybody in the chat room is saying, so let's see. And it is A. So chalk it up. We're batting 100 so far.
Yeah, we are doing good, aren't we?
Yeah.
We haven't missed one yet.
All right, let's see if we can get tripped up on this next one here. We won't. I know we'll get this one. What is the meaning of the term broadcasting in the FCC rules for the amateur service?
Yeah, we just discussed that.
A two-way transmission by amateur stations.
B, transmission of music.
C, transmission of messages directed only to amateur operators.
D, transmissions intended for reception by the general public. Yeah, those aren't going to work. I need binoculars for that.
All right. What do you think, Tommy?
Okay, well, I just answered the other one, but I'll go with this one.
Well,
again.
I'll answer it, just to be fair.
Whichever.
I know the answer to this one, so let me
Okay, you can do that one then.
All right, broadcasting. A two-way transmission by amateur stations? No, but I know for a fact broadcasting is not a two-way transmission. So we can just rule that one on out. B, transmission of music? It could be, but it doesn't have to be. C, transmission of messages directed only to amateur operators? No, they are not terming that as broadcasting in the FCC rules for the amateur service. D, transmissions intended for reception by the general public, and that's what the FCC is talking about there, and that's what everyone in the chat room says, Tommy. So,
And I would concur with that.
there you go. Transmissions intended for reception by the general public would be considered broadcasting.
Although we did mention music earlier, it might be broadcasting, so that's what I was talking about. But
Yeah.
if you were just fired up your rig and you started playing music, with no, I mean, you just can't do that.
You just can't do that, and you can't get on there and start broadcasting the news intended for the general public either.
Right.
Your transmissions have they've got to be intended for other amateur radio operators. They're not intended for the general public. Okay, what's the next one we got here?
Under which of the following circumstances are amateur stations authorized to transmit signals related to broadcasting, program production, or news gathering, assuming no other means is available? A, only where such communications directly relate to the immediate safety of human life or protection of property.
All right, let me just go over that question again before I go to the next one. Under which of the circumstances can amateur stations, are they authorized to transmit signals related to broadcasting, program production, or news gathering, assuming that no other means are available? Well, B, only when broadcasting communications to or from the space shuttle.
C, only where non-commercial programming is gathered and supplied exclusively to the National Public Radio Network.
Or D, only when using amateur repeaters linked to the internet. I'm
Okay.
glad this is your question,
Yeah,
Tommy.
I'm gonna work my way backwards. Only when using repeaters to the internet. That's not. I just don't think that's right. You're not supposed to really broadcast or do
No.
program production or anything like that on there. That's almost conducting business.
Yeah.
C, where non-commercial programming is gathered, supplied exclusively, no. To NPR, no. Why would they single out one
No.
network? B, only broadcasting communications to or from the space shuttle. I'm going with A, only where such communications directly relate to the immediate safety of human life or protection of property. And when it's emergency like that, everything's out the window.
Yeah, I think you're right, and so does everyone in the chat room there. And of course, you're right. That's when everything changes. When it's a safety issue, that takes priority over everything else.
If you don't have if this is an emergency, a real emergency, if you don't have a license, you find a microphone, pick it up, and holler for help. Everything's legal for
Yep.
that.
Yeah.
In that circumstance.
Okay, next question. Under which of the following circumstances may an amateur radio station engage in broadcasting? I think I hear an echo in here. A, under no circumstances.
B, when transmitting code practice, information bulletins, or transmissions necessary to provide emergency communications.
C, at any time as long as no music is transmitted.
D, at any time as long as the material being transmitted did not originate from a commercial broadcast station.
Okay, and this is mine to answer. So yeah, I'll work through them backwards. That seems to have worked for you. D, at any time as long as the material being transmitted did not originate from a commercial broadcast station. No, that's nothing to do with it. C, at any time as long as no music is transmitted. No, that's not correct either. Because we already know that you can't broadcast on amateur radio. B, when transmitting code practice, information bulletins, or transmissions necessary to provide emergency communications. Well, I'm going to say that's it, Tommy, although A, under no circumstances is what you would think at first, and we're kind of split in the chat room. We've got mostly B's in there, but we did have one A. I'm going to go with the B's. I think that we're allowed to broadcast when we're transmitting code practice, information bulletins, or transmissions necessary to provide emergency communications.
I think at first I thought it was A, but I've changed my mind because of the emergency communications clause at the end of B. So I'm gonna agree with you on B.
Yeah, I think that's it. There you go. All right, next question.
All right. When is the transmission of codes or ciphers that hide the meaning of a message allowed by an amateur station? A, only during contests.
You would think. B, only when operating mobile.
C, only when transmitting control commands to space stations or radio control craft.
Or D, only when frequencies above 1280 megahertz are used. I don't know why they like 1280 megahertz so well in these questions today.
Well, I don't think it's D, just because I don't think it would be frequency specific where you could hide the meaning of your message or encode it. Transmitting control commands to space stations or radio control. I could see that because you really wouldn't want someone hijacking
The space station, no.
the
No, we wouldn't want that.
B, operating mobile, that just doesn't even make sense to me, and only during contests doesn't make sense to me. So I'm going with C. Nobody gets the space station on our watch.
Well, we're seeing that everyone in the chat room is saying C, although we do have one that says, but this is something we need to think about changing in amateur radio. Yeah, I don't know. I don't see it changing, but C, only when transmitting control commands to spacecrafts or radio control crafts. That's it. Yeah, you know, because you don't want someone else taking control of radio control craft.
This kind of begs another question. Do they send control commands to the space station over amateur radio frequencies?
I would think no, but maybe it's packet radio or something.
Yeah.
You know, or maybe
I would think they would have their own bands. I don't know.
No,
it's interesting, isn't it?
No, I mean an amateur packet station. You know, if and I'm not even sure. You know, it's been so long since I played with packet. I'm not sure if command data is even sent to packet. But I guess maybe well, we know what the answer is, so I don't think we can just go on there and there's a joystick program on the internet where we can run the space station. But obviously there's
it's
something.
Like flying my quadcopter.
Yeah. Patrick says to ham satellites, AMSAT, CubeSats, etc. Yeah, you know, we don't want some pirate hijacking all our spacecraft, amateur spacecraft.
Right.
So, nope. It's there again. One more time, it's sort of a safety issue. That's the only time we can use codes and ciphers. All right, we got a few more questions here. You know, we like to cover a little bit of technical stuff. We're not all about rules and regulations here.
Oh no.
So, I wonder what we could talk about this month, Tommy.
Hey, wait. Hey, here. What about one of these?
One of those. What is the name for a current that reverses direction on a regular basis? A, alternating current.
B, direct current.
C, circular current.
D, vertical current. Circular current, that's a good one.
That is a good one, isn't it? Well, I'll take this one here. Let's see. It reverses current on a regular basis. A, it sounds like alternating current to me. I don't think it's direct current because it's not direct, it keeps reversing. It's not circular current. I'm not really familiar with that one. And D, vertical current, not familiar with that either.
No.
I'm going to say it's A, alternating current, because they've been saying that in the chat room for about the last 10 minutes now.
Yeah.
Yeah.
They must
So
have got
let's
the
see.
question pool.
They must have. There we go.
All right.
Hey, alternating current.
Imagine you got that one right. If you would have missed that one, man, I was going to take that oscilloscope home with me today.
No. All right, what's the next one there, Tommy?
What is the name for a current that flows only in one direction? A, alternating current.
B, direct current.
C, normal current.
Or D, smooth current.
I like smooth
You
current.
like smooth current? Yeah. If
I
we'd
really
had those
wish-
capacitors, we would have had some smooth
I
current.
really wish that were the answer,
Yeah.
but I'm sure it's not. C, normal current. This is my turn, right?
Yep.
C, normal current. I'm sure that's not. And I know it's not A because we just went through that, and it's going to be B, direct current.
Well, let's see if you're right. And you are correct. Direct current.
Yeah, pretty much everybody's going to get that one right. Even I don't know anybody on the planet that. Well, there's probably some people that don't know the difference between alternating and direct
There
current.
probably is.
But there's probably not a lot of them.
Well,
That's pretty much a freebie question right there.
yeah. As long as we're on the current topic, let me continue here. Which of the following devices or circuits changes an alternating current into a varying DC current signal? A, a transformer.
B, a rectifier.
C, an amplifier.
Or D, a reflector.
Okay.
What's D-star gear got to do with anything?
Yeah, that's true.
No reflectors.
No reflectors. Well, let's see. I don't know of a device called a reflector, so I don't think it's that. An amplifier doesn't change alternating current into a varying DC current, so it's not that. I know a transformer, that can step a voltage up or down, but it's still AC when it comes out of it, because we just measured one a minute ago. So it's got to be B, a rectifier, and that's what everybody in the chat room's saying. And we're all correct. It's a rectifier.
What electronic component allows current to flow in only one direction? A, a resistor.
A B, a fuse.
C, a diode.
Or D, a driven element. You know, that could trip you up if you just really didn't know what they were talking about. You know?
Yep. If I was still asleep.
Yeah, if you've been studying antennas real hard,
Yeah.
you know, for the last few hours.
Well, but we're not, so I'm sure driven element's not it.
Okay.
And D is diode, and I'm sure that's the answer because we
No.
just actually went.
C is diode.
C is diode.
Yeah.
A resistor, no. B fuse, we know that's not right. We know it's C diode because we just went through all that.
Yeah, that's what everyone's saying. And once again, the majority is correct.
Yeah. Have we got any wrongs this week?
I don't think we've had any, you and I haven't got any wrong, and I don't think
That's
I've
a
maybe
first.
seen one wrong answer in the chat room, and he corrected itself before we got it all out.
Yeah, it's been a pretty
So,
easy week. Everybody
yeah.
gets an A this week.
It has, you know. What are the names of the two electrodes of a diode? A, plus and minus.
B, source and drain. C, anode and cathode. Or D, gate and base. What's the answer, G?
It's C.
There's really
Anode
no
and
way to
cathode.
reason that out anyway.
No.
Yeah, that's you're just gonna have to know that one.
You're just, yeah. Anode and cathode. A gate and a base, they're talking about a different component here. They're not talking about a diode. Source and drain, they're talking about another component. Plus and minus. I guess maybe you could be talking about a battery. I don't know. But anode and cathode are what you got on a diode.
Yeah.
All
And I
right.
guess because they have ode on the end of them, you could use that to remember diode, anode, cathode. How is cathode lead of a semiconductor diode usually identified? A, with the word cathode.
B, with the stripe.
C, with the letter C.
Or D, all of these choices are correct.
I think it's B, although honestly I'm really not positive on this one.
Yeah. Mike says it's the commode. Nope. You're not positive on this one?
I think it's B.
You think it's B with a stripe.
Yep.
So you don't think that the word cathode is
I'm
written
sure
on
that's not written on there. And I don't
it? You
remember.
better look real hard. Nope.
And I know the letter C's not on there, so all of these are correct is not right. So it's got to be B.
I think you're right. And let's see. And it is B with a stripe. All right, Tommy, we got through those with no injuries.
Yeah, and 100% score.
A 100% score, I think maybe. Is this the first time?
I believe it is.
Okay. I think we could probably pass this.
Yeah, we got this
if we
one.
tried hard.
We-
All right, and by the way, on that last one, everybody said it was B in the chat room there. So, hey, I think those guys would have passed too.
I see an interesting question in the chat room. It's kind of irrelevant to this, but
Well, speaking of chat room, why don't we talk to them in the
it's
chat
about
room for a
that
couple
time.
of minutes?
Well,
Yeah.
okay.
And
Well,
that's what the instructions say right there at the bottom of the screen.
That's it. So I see one from Patrick that says, "I'm curious how many people who watch Amateur Logic don't have their license already."
You know, there's a good many.
There are, and I've been just dying to mention that because we get quite a few emails from people in the Facebook and the Google Plus groups that don't have them, that are working towards it, and that's actually what this show was for. This is really not Amateur Logic; it's just by the same people.
Yeah.
Hopefully to introduce it to people, amateur radio, to people that don't have their license yet, or give them a little motivation to kind of step up the game a little bit and study more and get their ticket.
Yeah, I mean that's kind of what we've done all along. It's just we're not strictly for hams, although I'd say the majority of our viewers are hams. Not all of them by a long shot. You know, there's a lot of guys out there, and I can't think of one in particular that has been following us for almost a full 10 years that still hadn't got his license, but he's thinking about it. But he's still watching.
Yeah.
You know, so we try to appeal to just, the general geeky type of tech crowd and, trip them and drag them into the exam stations. And
Yeah, we got
get them to-
the Raspberry Pi stuff draws and Arduino type things. They draw, a lot of people into electronics and computers and stuff. But although the bulk of our stuff's ham radio stuff.
Mike says the electronic makers, that's true. And Patrick said the rest of you should ask questions too.
Way to go, Patrick. Tell them.
Aaron says he doesn't have his license yet, and I have my ARRL book and I'm studying it. Way to go, Aaron. You'll get it. Just hang in there and you'll be mighty proud when you did.
Oh, yeah.
Then you can tell all your friends, I'm a ham radio operator, and they can say to you is, my uncle had a CB one time.
Yeah.
Which is what they say to us quite often. But, it's a great community, and you'll really enjoy being part of it.
Oh, it's great. It's one of the best things I've done.
Yeah.
I couldn't even imagine not having my ticket.
Yeah.
Well, what would I do on Thursday nights?
True. Yep. KG5CXA says, I watched AL and Ham Nation before I got mine. Thanks. Well, congratulations to you too.
And thanks for watching.
Yep. Thanks for watching.
For all of you guys and ladies out there for watching.
Yep.
If you didn't watch, we probably wouldn't still be sitting here doing it.
Yeah, that's true. Don says, what's the best way to be notified of the next Ham College episode? Follow at AmateurLogic or at Ham College on Twitter. If you don't do Twitter, just if you're on Facebook, join the AmateurLogic community there, or Google Plus community. We post on all these places.
All the usual.
Yeah, we don't really do emails. Maybe that's something we should consider.
Maybe so. Maybe so. It wouldn't be that hard to set it up.
Yeah.
People wanted to be notified, but then you kind of go through the deal of having to maintain the list and everything.
Yeah.
people, if anybody, not that
Yeah,
anybody
true.
would ever want off.
No, not. I mean, once they're on, but then you'd get into having to put those messages on there to be
Yeah.
legal. So I don't know if we'll do the email thing, but
If you're on Twitter, or even if you're not, sign up on Twitter and you can get notified when a tweet from one of us comes out using those accounts.
you'll have
and,
to
uh,
tell me
that's-
how to do that because I never get notified.
You probably have all your notifications on your phone and stuff turned off.
Well, yeah,
That could explain it.
that could explain it. Generally, well, I can't say a certain date, but we try to have Amateur Logics around the 15th of the month, usually before that, and Ham colleges just before the end of the month.
It's typically like the weekend before the end of the month.
Yeah.
But field day is this weekend, so we had to kind of move it up. And with my travel schedule with works, occasionally we have to kind of to be a little bit flexible with this one.
Yeah.
Amateur Logic is almost always on Friday night or Saturday night, though.
Mike says his wife watches too for the comedic content.
I could see that.
Yep, I could see that too. Let's see. KE0DZW said that's how I learned to make a ballon. Making your own ballon. What a novel concept.
Yeah.
I may have to try
You
that.
should do that.
Yeah. Ralph says Google Plus. Yeah, that's another good way to find out. Ray says my wife watches to do her intermediate license in the UK. You know, I don't know that much about licensing in the UK, but it's a little different. Gregory has been talking about it on the Facebook group.
Yeah. So
And-
is it close enough that what we're doing here is beneficial? It must be if she keeps watching.
You know, I really don't. I mean, I assume, you know, a lot of the things are very similar, but I think their licenses are their exams are different. I don't know that they sit down and take a multiple choice exam.
Yeah. I know that the theory stuff is all going to be the same.
Yeah. What time do you start? I'm in the Eastern time zone, Don is asking. We usually start at 7 p.m. Central, which would be 8 Eastern.
8 your time. Almost always is that, unless there's some weird.
Well, that's when it's scheduled. Sometimes we're 30 or 45 minutes late, just depending on what kind of technical difficulty we run into. But
yeah, it's when it's just us. The Ham College ones are a little easier. Sometimes when we have to tie Peter in, we have some technical difficulties with the Skype, and it's a lot more complicated setup. It's not nothing on Peter. It's just the way we have to put the system together here to get it all to work.
Yeah. KE0DZW says, I would like to see an episode or two on setting up digital PSK31 and such. You know, we'll have to revisit that on Amateur Logic again. We haven't done any PSK31 lately.
Yeah, right before last field day.
Yep.
I did that with the
about a year.
IC7200.
Yep.
Yeah, so it's about time to do that. I may do that on Amateur Logic because I'm wanting to get that set up on my 7100 I just got. And I may do that and try to get that set up on a PC and on a Mac, get both working on there.
So, I don't know, on the 7100, it doesn't have PSK built in it. You use a sound
No, but it's got the
interface.
sound interface built in it.
Oh, that's right, it does.
So basically
Yeah.
you just plug the USB into the computer and set up the software, set the filter and stuff on the radio, right?
Like shooting DX in a barrel.
Yeah, I hope so. I'll let you know, but I plan on doing that here very soon.
Yeah.
I haven't done much on HF Digital, and I'm kind of intrigued by it. I want to do more.
I've done a little, not a tremendous amount. You know, my rig has PSK31 and RIDI built into it.
Yeah.
You just plug a keyboard in and go with it, and I just haven't done it that much. I still kind of, well, I like being able to go on there and look at the super browser on PSK31 where you're seeing 20 or 30 different signals, conversations going all at once.
Yeah.
That is just cool. Well, I think we probably ought to wind it up and go get some supper.
That sounds like a good plan. But it was fun.
It was fun. And we appreciate everyone being with us tonight. We had a great time, even though Tommy was acting like an anode over there. I couldn't let it go. It'd be my last opportunity.
You can't take me anywhere.
All right. Well, thanks for joining us, and check back with us again next month about the same time.
Yep. Typically on Friday or Saturday, right before the end of the month.
And if you're operating field day this coming weekend, be on the lookout for November 5 Zulu November Oscar.
Although they probably won't be seeing that before field day unless you're going to really do some fast editing.
True. Yeah, they may not see this till after field day.
Yeah, but
never mind. No, I hope we caught some of you on field day.
Yeah, that'd be.
We had a great time.
It was fun. Whatever we did.
Yeah. All right, 7-3.
73, everybody.
The positives are coming through that diode. It's only going in one direction toward the cathode there. So you can think of me as a cathode and Tommy as a
I'm gonna get a T-shirt with the hand on it that says "I'm with the anode."
oh.